Okay. Now we're going to talk about set and drift. Set and drift are the names for how your boat gets affected and impacted by either wind or current. Basically, any force that's causing you to move off course from your intended track line. So we're going back to the track line that I made before here. But you can see as we were following this from 0800 to 0806, at 0812, I put down a new fix. Let's say we checked our GPS position and we found that at 0812, instead of being over here at the DR position like we expected ourselves to be, we're way over here. What could have happened? How did we get so far away from where we're supposed to be? I mean, if our position was like right there, it wouldn't be that big of a deal, or right there, or right there. But we're pretty substantially far away. And if we continue doing what we're doing without changing anything, we're going to end up way out over here instead of ever reaching our waypoint. So we don't necessarily know what happened. Realistically, in a situation like this, you can expect it was probably current that pushed you all the way over here. And you know that it's been applying to you ever since your 0800 fix, because that's the last time you knew exactly where your ship was. So between here and here, you have been constantly being affected by some kind of current that's been pushing you over and over until you ended up right here. So the way we measure and calculate exactly what the direction and magnitude of this current was is we break it down into set and drift. Set, S-E-T, is the exact direction of the current, and drift is the speed that it was pushing you at. So we'll start with set. Now, set is really easy to calculate. You just connect the dots between the DR position of where you were supposed to be at 0812 and your true position at 0812, like that. You connect them together, and then you measure that line that I used to connect them. You measure that angle, and you see, grab your second triangle. If you move that over to a meridian so you can measure its angle, you get an angle of 257. Okay. So the current is moving in the direction of 257, and that's what's been pushing you this whole time. Or at least your set is 257. How fast is it though? What is the speed of the current to be doing this to you? Well, for that, you don't know its speed, but you know how far it moved you, and you know how long it's been applying to you, because it started here and is now got you here. So now you can measure this distance, like so. Bring it over to your distance scale, right here, and you measure it, and you get 0.7 miles. I don't know why everything seems to be coming out to 0.7, but you get a distance of 0.7 miles. So in 12 minutes, from 0800 to 0812, it moved you 0.7 miles off target. Get your calculator? Okay. 0.7 times 60. You moved 0.7 miles over a total period of time of 12 minutes. 3.5. So you are getting impacted by a current that is 3.5 knots moving in the direction of 247 true. That is your set of 2.247 and your drift of 3.5 knots. Perfect. Now you know exactly what the current conditions are and how they're impacting you. Well, this doesn't solve every problem, because you need to actually do something about this now. So what do you do? How do you compensate for that? Well, what you're trying to find now is called a course to steer, CTC, CTS, course to steer. And it's just a new course you should try to aim for that will compensate for the impact of the current pushing you away. So if the current is pushing you this way, you obviously should aim up this way to try to counteract it. And you aiming more northerly and it pushing you more southerly will, if you aim it out correctly, cancel each other out to end up keeping you on your original track line. So even though you've been pushed a little bit of ways away, at least you can continue to follow 135 now. The way you measure out what this new course should be, and I won't get into the specifics, but it's just based around vector triangles, how this works. But all you need to do is you need to take the set angle that you originally measured, move it out in the opposite direction onto the other side of your track line, take your drift distance that you measured between your DR position and your true position, measure it in the opposite direction from in the way that you just extended your your set direction, make a little tick mark, and then connect that point to your original fix of 0800, like so, and then measure that line. And the angle of that line is the new course you should follow if you want to stay on track and make good 240. Make good, course made good, means the course you actually follow. So if you aim for this course with the current conditions given, you will make good a course of 135. Measure it out. Bring it over to your meridian. There you go. And I'm getting 125. Okay. So you are headed 135. But going course 135 has caused you to drift off track based on the current to over here. From here, if you now aim up to course 125, like you just measured, you will make good a track of 135 because the current will now push you down to 135 and you can continue the way you were originally going. You're a little bit off track, but at least you're moving in the correct direction. So let's try that again. We'll do it one more time. We'll do it. Now let's pretend that your 0827 waypoint, you actually have a fix there at 0827. And let's base it off of now your 0842 DR position. So if this is your DR position, let's say at 0842 you took a fix and you were up here instead, 0842. So you've been pushed off track again, obviously in a different direction than you were before. So this is some new current pushing you this way. So what is your set? Well, for your set, you just connect the dots between your DR position and your fix, like that. And then you measure its angle. You bring that over to your meridian, like I've done. Remember, you're measuring from the DR position to the fix. And then you find what that angle was. By the way, if you're confused, I haven't done this yet in a video, but you can have your triangle upside down and it doesn't change anything. You can either measure it down like this if it was one way, or if it's upside down like this, you can measure upwards and it still works. You know that the angle is going northeasterly, so you still need to read the easterly numbers, so the black numbers. And you can see you're going from 20 to 30. So there's 025, 026, 027. So your set is on a track of a course of 027 up here. And your drift, if we measure it, there's your distance. You bring that over to your latitude scale to measure distances. You get, wow, 0.7 again. I don't understand how that keeps happening. 0.7. So you have a set at an angle of 0.25 and a drift of 0.7 you moved 0.7 nautical miles. So then if you apply that 0.7 times 60, and then you divide it by your time. But remember, your time now is 15-minute intervals. This was 15 minutes from here to here, not 12 minutes like before. So instead of dividing by 12, you divide by 15, and you get 2.8. So even though you moved the same distance by coincidence that you did last time was over a shorter period of time than it was this time. So instead of having a drift of 3.5, you have a drift of 2.8 because it took longer to push you the same distance. So you had a set of 0.25 and a drift of 2.8. What are you going to do to compensate for it? Well, you take your angle of set, you apply it in the opposite direction, you take your distance of drift, like so, you apply it in the opposite direction, you mark the tick mark that happens to be right in the center of my label for the track line. That's not a big deal as long as you can still see what you're doing. And then you connect it back to your original fix. Like that. There is your new course to steer. You bring your triangle over to measure it. Set your window over the meridian. Never forget to do that. Drop down here, and you can see this is a course of 0.89. So even though you're trying to make good 0.80, if you follow track 0.89, the current of 0.25 degrees at 2.8 knots will push you upwards, and you will end up making good 0.80 like you originally planned to do. So that's how you do set and drift and course to steer.